So on the midterm, I'll treat you with the classic square root treatment. So whatever like you had in percentage, I'll take a square root, and also I'll give it another chance to. I'll give another chance to whoever who might think even after taking square root you may be in a failing grade. So I'll give you another chance to take a look at, kind of to take a shot at the midterm, but like you'll be capped at 60%, and I won't be taking square root if you do that.
Is it best of, or is it complete reset?
It's a so if you do that, it'll be a reset.
Okay.
All right. And please contact me like as early as possible if you do that. Hmm?
Are the grades on Saturday?
No, the thing is I don't want to give you the corrected version before people actually have. If anybody wants to redo this,
No, is the grade on Stellar? Sorry.
the grades are not right.
Okay.
So I'll post it after everybody is
Okay.
right. All right. Also, but to make it clear, like it's not I'm gonna post a grade and you decide. It's you should decide, and if you want to take this or not without
Does that
seeing the
mean
grades.
Nobody passed the exam.
No, it's pretty. I mean,
Sorry,
some of you did pretty well.
I misunderstood. So we can retake the exam if we were failing, but we need to decide before we know our grade if we want to retake the exam.
Right, yeah.
Same exam?
It's the same exam.
How?
How will we know?
How would you know if you are failing? Okay, let me see. Well, I can. How would you know if you want to retake it or not?
Yeah.
So if we retake it, our first exam is not considered a whole.
Yeah, but like you'll be taking the same exam. I haven't released any answers or anything, right?
Right. So I guess the question is, how do we make that decision based on not knowing our score from the exam?
Do you kind of know like how much you know the answers, right? Or no? Okay.
It's better if we just get a sense of
You want to get the score?
and then from there.
Okay, sure. I'll release the score sometime either tonight or tomorrow morning, and you can decide.
Okay, thank you.
All right. Okay.
What was the square root you talked about?
What was the?
What was the square root?
He's taking the square root of your grade as a decimal so that it increases by some fraction.
Yeah.
Right, so like square root of 0.2, if you got a 20%, would be like 40%.
Wait.
I think that's how that works.
No.
Square root of 16% would be 40%.
Oh, yeah. So obviously I should retake the exam.
All right.
Will we get a sense as well of like the average so we can determine whether or not?
So
I
you
think the
also want.
conclusion is we did really badly. I think that's the takeaway.
All right. Sure. I can also post some statistics. Okay. All right. So this is the last lecture on partial differential equations, and the primary objective in this lecture is to tell you how to derive the kind of weak forms we have been talking about in finite elements, and use a software to solve these differential equations automatically on these weak forms. All right. Okay. So first of all, what is a weak form? A weak form can be viewed in two ways. One way is a variational form of the energy minimization we have been talking about. So if the finite element is minimizing a certain energy, which is a function of the solution U over all the space of U's, a weak form, so this is the energy minimization or energy form of our problem. The weak form correspondingly is really the derivative of this energy with respect to u equal to 0. Okay, or in some sense it is saying that the energy of u plus any delta u minus E of u is going to be equal to 0 for infinitesimal delta u. So let me just write it as u plus delta u times epsilon for infinitesimal epsilon. Okay, does it make sense? So that is saying that for infinitesimal epsilon and any delta u. So what it says is that if you can choose a delta u in which the energy after perturbation is going to be different from the original energy, then no matter if the perturbed energy is larger or smaller, right? So if the perturbed energy is smaller, then it will violate this minimization statement, right? Does it make sense? So this minimization says that the solution u is among all possible u's the solution that will give you the minimum possible energy. So it says that it's impossible to perturb this so that this energy is going to be even lower than this. So from the energy minimization, we already know that this has to be less or equal to 0, right? Oh, actually greater or equal to 0. That's from the energy minimization statement.
So, but then if that was true, wouldn't the energy function have to be constant for all u?
Infinitesimal epsilon. So if you add a perturbation of finite size, this guarantees that the perturbed energy is going to be larger, right? Does it make sense?
First order.
To first order, this says that to first order it should be constant.
Got it.
Right, so because the reason is because if to first order this is not constant, I can prove right now that this perturbed energy can neither be greater than the original E nor can be less than. So first of all, it cannot be less than because the original energy is already the minimum. Also, it cannot be greater because if this is actually strictly greater, I can take the minus epsilon, right? Because we are looking at a first order statement. This energy difference is actually a linear function of epsilon. So if I take the minus epsilon, this will be actually less, which again violates this energy minimization. Right? Does it make sense? It is saying that, let's say, for any epsilon, let's say this is the energy, right? So what this equality statement is saying that the derivative of E with respect to epsilon has to be 0. It cannot be positive, which is going to be like that. It can also not be negative, which is going to be like that. It has to be exactly 0, so that at no values of epsilon, the energy with a non-zero epsilon is going to be less than the energy with a 0 epsilon. Right, so at this point the value is E of U, the solution that minimizes. So this cannot be true, this cannot be true, and this is the only possible case. So this with an equality sign is the weak form of this partial differential equation. Right? Does it make sense?